Assalamualaikum. We are from group HG5. We are going to present our IDP, which is measuring muscle activation parameters with FSR sensor cuff in lower limb injuries for UTHM athletes. Our supervisor is Dr. Muhammad Hazli bin Mazlan. Before start, let me introduce myself and my other group member. So our leader is Katiroban anak lelaki Ari Walagan, Ahmad Amin Amri bin Azrai, Muhammad Akmal Hakim bin Muhammad Jamal, Muhammad Amin bin Sulimat, and myself, Farzatul Faisha binti Lailang. So let's start with introduction first. Athletes at the University of Hussein in Malaysia commonly face lower limb issues due to intense sports training. So the high reliance on lower limb strength contributes to frequent injuries such as skin injuries, joint problems, soft tissue damage, and fractures. The intense sports activities and conflicts increase the risk of lower limb injuries and technical mobility issues. In case of lower limb injuries, athletes should consult healthcare professionals to avoid long-term career risk from poor rehabilitation practices. We are collaborate with the University Physiotherapy Department at Pusat Kesihatan University PKU to enhance lower limb muscle activity measurement. Our aims in this project is to provide useful data for more effective rehabilitation, improving athletes' well-being and performance.
Hi, my name is Muhammad Amin bin Sulimat. My matrix number is CE200003. The problem statement of our project is the effectiveness of manual muscle testing is crucial for the development of mobility and prosthetic fitting for rehabilitation purposes in individuals with lower limb injuries. Challenges arise due to the lack of standardized MMT procedures, grading scales, and application method. This leads to difficulties when patients seek consultation at different medical centers, as the procedures and grading vary between practitioners, necessitating repeated MMTs.
Hi, Assalamualaikum and greetings to panels. My name is Muhammad Malakim and Muhammad Jamal. My matrix number is CU210001, and today I'm going to explain to you about the objective of our project. So, our project explores the synergy between FSR sensor technology, Arduino microcontroller, and 3D printing to analyze muscle performance. We introduced the development of FSR sensor circuit interface with Arduino for real-time force measurement, and highlighted the creation of versatile 3D printed cuff model adaptable for various applications. The primary focus lies in using the FSR sensor cuff system during manual muscle testing to discern difference in muscle performance between peak and non-peak activities. Next, the integration and collaboration across diverse disciplines to fuel our project, aiming to unravel valuable insight into muscle functionality with potential implication in physical therapy, sports science, and healthcare research. So, it summarized the core element of the presentation, outlining the technology integration, objective, and potential impact of the project on understanding muscle performance. Adjustment can be made as needed to align with the specific detail highlighted in our project. So that's all from me. Next,
Hello, my name is Ahmad Amin Amri bin Azrai. My matrix number is CE2001X6. Now I would like to present about the list of the component. Firstly is the most important component for our project is Arduino Mega. We use it as a processor for this project in process the data. Second is jumper wires. We use it in connection between each FSR sensor, and then the connection to the Arduino Mega from the sensor. Third is 100 kilo ohm of resistor we use for the circuit connection for the sensor. And then donut board we use as a root for the connection of the FSR sensor circuit. And fifth is FSR sensors, the most important component that we use for the project. We use around 8 FSR sensors in detection of muscle movement for lower limb. Third is 3D printed cuff housing. We use it as a place of FSR sensor and detect the muscle movement.
Hi everyone, I'm Kadiron here. I'm going to show you the demo project. So the FSR sensor is already embedded in the 3D curve system with Arduino here. We already connected all the wires into the Arduino. Now first we need to set the threshold value for the normal muscle activity level in the Arduino coding before beginning the analysis of the patient muscle activity. For the configuration, the Arduino board will be connected to the computer via the USB port. Let's select the board, Arduino Mega, and then the COM is COM4. Okay, so now let's update the coding. Once the coding is verified, we need to upload the coding into our Arduino Mega. Okay, now the coding is already updated. Now for configuration, we need to open up the Excel and configure into data streamer. So we select the COM to configure into our data streamer, and then we need to select the USB port of which the Arduino is connected into the data streamer settings in Excel. So the data capture rate in data streamer is configured to be 50 millisecond, and the row offset to channel is 8 based on how many signals, 8 FSR we are using, right? So now the FSR sensor is now placed directly onto the skin area where the muscle activity would be analyzed on the affected part. The subject are expected to participate in variety of the exercise, which is night cycle, either strength will be conduct. So now we conduct the strength exercise. Every test will be carried out at least 5 times. Well, in our Excel streamer, we can see the each channel have their own color, represent own color. So based on the each FSR sensor, we can analysis of the muscle performance in peak and non-peak muscle strength during this type of activity. Thank you.